Okay, so moving to the next question. The question says in here we have a showroom, okay, for a department store is to be rectangular, okay, with walls on three sides. So in here we have showroom for a department store, okay. It will be rectangular. They are saying it's rectangular with walls. So we have walls over here on three sides. Walls on three sides only. Okay, so this is the first side. Okay, this is the second side, and this is the third side. Okay, 6 feet door opening on the two facing sides. So in here they are opening doors in this side and this side because they are saying in the two facing sides. So opening doors. So let's say this is my first door and this is my second door. Okay, now they are saying that in here 6 feet, so the distance 6 and 6. Okay, so if in here, okay, so if this, the total length over here, if it's equal to x, that means this part is equal to x minus 6 for the remaining part for the wall. So if this is x, this is x minus 6. Okay, now also on the third side, they are opening a 10-foot door. So in here we have 10 feet. Okay, so that's a 10-foot door, big door. Okay, so this is 10, which means in here, if this part is y, then the remaining part, it will be y minus 10. Okay, so now in here 10-foot door opening on the remaining wall. The showroom is to have 800 feet square of floor space. So in here, since if you don't know what is that, this is the area. Okay, so since the unit is feet square, that means in here this is the area. So 800 feet square, okay, of floor space. What dimensions will minimize the length of wall used? Okay, so we need to minimize the length of the wall used. Okay, what is the length of the wall used? So the total length of the wall, it will be the remaining wall from this side and the remaining wall from this side plus the remaining wall from this side. So it will be 2 times x minus x, this is x minus 6 because we have two of them here, and in here plus y minus 10. Okay, now what about area? What is the area? So in here we need to minimize the length, so we need to minimize that. Now what is the area? This is the substitution relation. So in here this is equal to x multiplied by y, okay, which is equal to 800. So I can say that y is equal to 800 divided by x. Then after that I can substitute in the length or the total length. And here 2 times x minus 6 plus, instead of y I will write 800 divided by x, k minus 10. Okay. Okay, that's it. Now in here after that we can say okay. Now for finding the derivative, let's start by finding the derivative. So this is going to be, after simplifying, let's keep on the black one. So L total, okay, this is equal to 2x minus 12 plus 800. This is 800 divided by x minus 10. Now we can start finding the derivative. So in here it will be okay, so start with the derivative. So L prime, this is equal to 2, in here 0, in here this is plus, not minus. Okay, so this is going to be minus 800 divided by x squared, and this is 0. So all we have to do is just making the denominator equal to 0 by making this equal to 0 to find the zeros. So zeros, it will be by making the denominator the same. Let's make the denominator the same first. So L prime, it will be equal to x squared, 2x squared minus 800 divided by x squared. So by just making the denominators the same. Okay, so the zeros in here, I have 2x squared minus 800 equals 0. So after taking the 800 to this side and dividing by 2, which is going to be equal to 400, then that will I have to take the square root of 400, okay, which is equal to 20. So x is equal to positive negative 20, okay, because we are taking square root for both sides, don't forget that. And the undefined value, it will be in here x equal to 0. What about the domain of the original function? Now in here, the domain of the original function, now for sure in here, r, it will be r minus the 0. This is the domain of the original function, because in here this is r, in here r, and here this is r minus the 0 of the denominator, which is 0. So which means in here we have r minus